Okay, the last thing we have to talk about are decimals. We'll start just by talking about the place value system. It's something that's probably pretty familiar to you. And then just fraction decimal conversions. So writing 2,431 in expanded notation. This expanded notation might not make sense right now, but as soon as you see me put up the answer, you're going to know what I'm talking about. That's 2,000 plus 400 plus 30 plus 1. What that does, and the reason you were asked to do that in elementary school, is to realize that if that 2 is in that position, it means 2,000. That if 3 is in that position, it means 30. That the place where the digit is actually has a very big bearing on how much it's worth. So for 2.431, this is something we probably didn't do in elementary school. That's 2 plus 4/10. What would come next? 3 100ths and 1 1,000th. So the place value names, there's just this little graphic I found on the internet. Obviously we have our hundreds, tens, ones, and before that would be thousands, and so forth. The digit after the decimal point is the tenths, and then the hundredths, and then the thousandths, and then the 10,000ths, and then the 100,000ths, and the millionths, and so on. Okay, that's just the place value system, and that's going to help us with our adding and subtracting of decimals. First of all, converting fractions to decimals. We've got 3 examples we will work through. 9 25ths, 7 over 33, and 7 over 11. So we're going to use long division. For those of you that don't remember long division, we're going to hit it twice during this semester. Right now it's just with numbers, and the next time you see it, it's going to be with polynomials, which is a lot more involved. So get used to it here. The thing that we'll do over and over is divide, multiply, subtract, bring down. That's what the DMSB is for. So first thing, we'll take 25 into 9. 25 doesn't go into 9, so I have to say that's 9.0. 25 goes into 90 3 times. 3 times 25 is 75. 90 minus 75 is 15. Now how many times does 25 go into 15? It doesn't. So we have to add another 0. 25 goes into 150 6 times. 6 times 25 is 150. Subtract. We have a remainder of 0. So that decimal, see how the decimal is 9.00? That decimal travels straight up, so we get 0.36. Okay, let's do this next one, and on the next one we'll look at the DMSB over and over. So first of all, divide. 33 doesn't go into 7, but 33 does go into 70. So I divide 33 into 70 and it goes 2 times, so that's D. Next letter's M, multiply. 2 times 33, 66. That's divide, multiply. Next step is S, subtract. 70 minus 66 is 4. 33 doesn't go into 4, so I have to add a 0. 33 goes into 40 1 time. So I have 1 times 33 is 33. Subtract. I have 7. Well, okay, 33 doesn't go into 7. Put another 0 on. Bring down another 0. That's B for bring down. 33 goes into 70 twice. Well, 2 times 33 is 66. What's happening here? I'm just going to keep going back and forth and back and forth. I'm going to have 2, 1, 2, 1, 2, 1, 2, 1 on the top. Another way to write that is 0.21 repeating. All right, let's do 11 into 7. Doesn't go into 7, it does go into 70. It goes 6 times. 6 times 11 is 66. Subtract, and I have 4. Bring down a 0. 11 goes into 40 3 times. 3 times 11 is 33. Subtract, and I get 7. Now look, it's happening again. So I have 0.636363, or 0.63 repeating. So if I have a fraction and I want to convert it to a decimal, I use long division. Now the good news is if I have a decimal and I want to make it into a fraction, it's a lot easier. Okay, all we have to do is think about the place value system. So 0.45, that's 4/10 plus 5/100, or 40/100 plus 5/100, or 45/100. Now, you don't need to put those middle steps in. You can just look at 0.45, and 0.45 has 2 decimal point places. So we're just going to take 45 over 1 with 2 zeros. However many decimal places there are is how many zeros we need to have on the bottom. So can we do it in one step? Just look at the last decimal place, and that's how many zeros we need. In other words, look at how many times we move the decimal point. So for 0.181, well, we'd need to move that decimal point 3 times. So we'd have 3 zeros on the bottom and 181 on top. Not too bad, huh? All right, 10.09. Okay, I need to move that decimal point twice. So I have 2 zeros on the bottom and 1,009 on the top. Okay, 0.145. How many times do I need to move that decimal point? I need to move it 3 times, so I have 3 zeros on the bottom and 145 on top. For 14.7, how many times do I need to move the decimal point? Just once. So it's just 10 on the bottom. 1 zero and 147 on top. Okay, for this last one, how many times do I need to move the decimal point? The digits are exactly the same as they were in the last problem, but I've got to move that decimal point 5 times. So I've got 5 zeros on the bottom and 147 on top. So when you're converting a decimal to a fraction, just look at how many times you need to move that decimal point to make it a whole number, and that's you'll need a 1 with that many zeros on the bottom. Okay, another way to write these, that could be 10 and 9/100. That one could be 14 and 7/10. They're the same thing, it doesn't matter. Okay, what if we have a repeating decimal? I'm not going to show you how to do them in general, I'm just going to show you how to do the very easy ones. If you have .AAAAA repeating, then that's A over 9. So if I have .222 repeating, which we saw earlier in this lecture, that's 2/9. To check, I'd take 9, divide it into 2, and I'd do the long division. I get another 2, carry it down, and it's just going to keep being 0.2, 0.2, 0.2. So 1.1 repeating would be 1 1/9. The 1, because that's the number before the decimal point. The 0.1 is repeating, so that turns into 1/9. 3.7 repeating. 3 7/9. 3.7 is 3 7/10. Look carefully and look at the difference. The 3.7 repeating got the 9 in the denominator. The 3.7 without the repeat sign, we just change it to a decimal, or change it to a fraction the normal way. That is decimal fraction conversions, and this is the end of lecture 1. I'll see you for lecture 2.